So this is a formula you're going to use. So number of data given, n equals to 2. So P2 x is going to be y1 L1 x plus y2 L2x. The y1 subscript, because n is going from n is the number of n is 2. So we're going to have the subscript maximum. This is a subscript k here, yk, and then yk becomes y1 and y2 for 2 datas. Similarly, we're going to have this L1 here, it's the Lagrange polynomial. For 2 datas, we just have 2 terms here. L1x is going to be, go to this formula here, you can see k is 1, k is 1, x is I is 1, okay, the I is 1. So it's going to be 1 year, and then 1 year, the subscript. And then next, you fix k equals to, sorry, still k is 1, but next I is 2. So wherever there's k is still 1, but I is going to be 2. Multiply by x minus x2, x1 minus x2. Okay, any question on that? So division by x1 minus x1 is going to give you x1 minus x1 is going to give you 0. So you're going to get a division by 0, which is not allowed in mathematics. So we're not going to use this. So L1 is x minus x2 divided by x1 minus x2. Now next we go into, now fix k is 2. So do you guys have any question on the previous one? Any questions so far?
So have to times y1, am I right?
Right, pardon? Oh yes, forgot about that. Thank you. So this formula here, we have y1, so we're going to times by y1. For right now, we are only developing L1. Later on, when we have, right now we have Lx here. Later on, we're going to put it inside here. Okay?
Okay, sir.
Okay. Thank you. The next k is 2. As usual, I goes from 1 to 2. So this is going to be L2x, same as before. Now k is 2. When k is 2, I is 1, k is 2. So in that case, you're going to get x minus x1 divided by x2 minus x1. And then multiply that by k is still 2. Now you have I is equal to 2. So we're going to have x minus x2 divided by x2 minus x2. So again, you have on the second term, on this term here, you have a division by 0. So it's not, you're not going to be using this. X minus x1, x minus x. x2 minus x1. So once you have it, you go and plug into the formula. You're going to get y1 x minus x2 x1 minus x2 plus y2 x2 minus x1. Any questions so far?
No, sir.
No, sir.
So these are the data points given to you. This is, for example, x1, x2, and this is y1 and y2. Just use it in that formula. Y1 is 0.09983. X2 0.2, 0.1 minus 0.2. Y2 x minus 0.1 divided by 0.2 minus 0.1.
Y2 is 0.19867, sir.
Okay, thanks. What is y1? Y2? Okay.
0.19867.
And 867. So once you multiply them out, you're going to get, that's going to give you 0.09983 0.9983 Okay, that's the Lagrange polynomial. So that's a Lagrange polynomial. So now question is asking, after you find the polynomial, then after finding this polynomial, now you can find any value in between 0.1 and 0.2. In this case, you are told to find the value of sine x when x is 0.15. So 0.15 is in between 0.1 and 0.2. Remember, this is numerical analysis, and this formula is only an approximation. So P2 0.515. Okay, there's a minus sign here that I missed. It's a minus sign. Supposed to be a minus sign there. It's okay. It's supposed to be a minus sign. 0.9983 when x is 0.15, 0.15 minus 0.2 plus 1.9867, 0.15 minus 0.1. If you do the mathematics carefully, if you don't have a calculator, you have to be very careful if you're going to do it by hand. If you have a calculator, you have to carefully punch it in, and then try to your best not to give your answer at least like 5 or 6 decimal places. To give your answer no less than 5 or 6 decimal places. So if you give something like 0.1, okay, if you give me something like 0.4, I will give you, if you cut the decimal places, I will cut your points. Numerical analysis. This is not an exact solution. This approximate solution should have as many decimal places as possible. Especially your answer is 0.1 is a small number, so you have to include many decimal places. Okay, this is an approximate solution. And then if you compare this with the exact solution, usually you can get some error. It's called truncation error. Okay, you will not be tested on truncation error, but I just wanted to mention there's an error calculation involved. It's called truncation error, and it's given by truncation error, abbreviated TE. This is a function of E, y, x is equals to yx minus p and x. But this is an actual, and this is approximation. So yx is the, you know that yx is approximated by yx is approximated by So this is just for your knowledge because this is in our syllabus. I'm just telling you T error is x minus x1, x minus x2, x minus xn, y to the power of n. This power of n here is a derivative, order of derivative. This Quigley's sign here. So like this is a power of derivative, order of derivative. Of derivative. And this is the error. So for example, in this case, n equals to 2. So your error is going to be TE this x minus x1, x minus x2, y2 divided by 2 factorial. So when x equals to 0.15, so you plug in those values in the TE. X is 0.15, so this is going to be 0.15. X1 is already given in the table. This is minus s. Why there's a minus inside here? Because you know y is equals to sine x. The first derivative is equals to cosine x. The second derivative is equals to minus sine x. And that's why you have a minus sign inside here. X is the error. X is, in this case, you replace the x with the error. So to calculate the error, so once you calculate this, you'll get 0.0125. The error must be less than 0.0125 multiplied by the maximum value of sine x. Okay, it has to be less than the maximum value of sine x. So now I need to put it TE, absolute sign, because we are ignoring all the negative signs. And please note that x is in between 0.2 and 0.1. The truncation error is 0.0125. multiplied by sine 0.2. Okay, we already replaced the error with 0.2 because of the condition here that says the maximum value of sine x, sine will be bigger, sine x will be bigger for bigger number, right? So sine 0.2 will be bigger than sine 0.1. So we put sine 0.2 here. Calculate that. 0.0125 sine 0.2. That's a truncation error. There's an error between the actual and the value approximated by the Lagrange polynomial. So this is just to show you that we need to calculate the error when we do numerical analysis. For the trapezoidal rule, right? We derive the formula, and this is the formula. And then I showed you how you can apply this formula to find the area under the curve. The integral is same as finding the area under the curve. So this is the curve. So you're finding the area in the curve. So you can split the area under the curve into how many intervals? 5 intervals in this case. Okay. So each interval has equal step size. Each interval has 1 interval, 2, 3, 4, 5. Each interval has the same step size. Using the trapezoidal rule, approximate the value of the integral from 0 to 1, integral from 0 to 1 over 1 plus x. You can use 4 equal subintervals. So 4 equal subinterval, therefore n equals to 4. Subintervals can be calculated by taking b to be 1, a to be 0, then divided by n, number of subintervals. Is 1 over 4, 0.25. Okay, you start at 0. Start at 0, you add 0.5, and then you add 0.5, add 0.5, add 0.5. So next you plug in these values into this. You plug in 0, you get 1 over 1, 1, 0.8, 0.666, 667, 0.57, 1429, 0.5. So this is like 1 over 1 plus 0. This is like 1 over 0.25. And this is 1 over 0.1 plus 0.5. Any question? Then you go and plug into that formula. I is equal to delta x over 2. Use substitution. U is 1 plus x. Du is a dx. So when x equals to 1, u is equals to 2. When x equals to 0, u is equals to 1. Because I already defined my u to be 1 plus x. So I'm trying to, I've already changed variable to u. So I also have to change the upper and lower limit. When x equal to 0, u is equals to 1. When x equals to 1, u equals to 0. So with this substitution, now my upper limit and lower limit is 1 to 2. It's 1 over u, du. So that's going to give you ln u, 1 to 2. The ln u is ln 2 minus ln 1. ln 1 is 0. So it's going to be simply ln 2. Which is around 0.69317. It is continuously going on. It's a very long, there's a very long decimal places. So the error is going to be the exact minus the approximated is equals to ln2 minus 0.69 the absolute value. Because error, we are interested in just knowing the absolute value. So that's going to give you 0.693147. So that's the error. So you might be getting a problem just like this for trapezoidal, where you have to do the numerical part, and then you also have to find the exact value and solve it, and then find the error. Here is first you must be able to put the matrix in the augmented form like this. See, the coefficient of x1 is 1, the coefficient of x2 is 1, the coefficient of x3 is 1, and is equals to 1, so you put 1. The equal sign 164, you put here 164. Then you put a line there. And then you go to row number 2. So row 1, row 2, and row 3, row number 2, and take the coefficients and put here 4, 3, minus 1, 6. And 6 is not the coefficient, is the number after the equal sign. Then you have coefficients 3, 5, 3, 3, 5, 3. Is that difficult to do? This is called the augmented matrix. See, the idea is you just want to make all these go to 0, this part here. So you want to make this all go to 0. Let's say if you get just, for example, x1 plus x2 is equals to 3, x1 plus 3x2 is equals to 10. If you get something like this, then your augmented matrix will be like this. 1, 1, 3. 1, 3, 10. So your life is much easier now, right? You just have to make this go to 0, and these two have to go to 0. So if you get a 2 by 2 matrix, it will be much easier to solve, isn't it? You get a 3 by 3 matrix, then you have 3 terms that you must make them go to 0. And then you have another 3 entries here that you must make them go to 0. Okay, if you look here, what the R2 minus 4R1 means. R2 means you're going to perform the operation on row 2. What are you going to do to row 2? You're going to subtract row 2 with 4R1. So you're going to multiply the row number 1 by 4 and subtract that from row 2. In so doing, you end up getting a 0 here. And next, you're going to perform an operation on row 3. So what operation you're going to perform? You're going to subtract row 3 by 3 times row 1. So you multiply row 1 by 3 and row 1 by 3 and add that to subtract that from row 3. By doing that, you'll get this 0, 2, 0, 1. So now you already achieved a 0 here, and then you need to achieve a 0 here. Then you're going to try to get a 0 here, 0 here, and 0 there. If you continue operation, this is something only you can teach yourself. Okay. Like in this one here, row 1, this one row 1, to row 1, what operation is performed on row 1? You add row 2 to row 1. And this is your row 1. Now you're adding row 2 to this row. Once you add that, you will end up getting this. Then you are also getting a 0 here. So you look for opportunities like this. Then only you add. If it's going to make you this one of them go to 0, then you perform the operation. And next one, to row number 3, you're going to add 2 times row number 2. So you take the row number 2 and you multiply that by 2 and you add that to row 3, you end up getting this. So earlier on, before doing that, it was 2. After adding that, you get 0. And then the last one, still you have to aiming for, you still need to get a so you can still need to get a 0 here and a 0 there, right? You need to get a 0 here and 0 there. But this operation going to accomplish that. If you do this, one operation is row 1 subtract by 4 over 10 row 3. In so doing that, you will be able to eliminate one of these. You'll be able to eliminate, replace this -4 with 0, I think. The next one, to row number 2, you subtract 5/10 multiplied by row 3. In so doing, you replace the -5 with 0. You don't worry about what you get in here, you just worry about this part here. So once you get 0, so for Gauss-Jordan, you must do this. And then at the end, what you need to do, you need to get rid of the minus sign also. And then you also have to change this to 1. All of them has to be 1 and must be all be free from any negative sign. In order to get a negative sign here, in order to get 1 here, we divide through the entire row by -10. So you'll get this. -10 divided by 0, 0 divided by -10 is 0, 0 divided by -10 is 0, -10 divided by -10 is 1, 5 divided by -10 is -1/2. Okay. So once you have achieved this, you're done. Then you go x is 1, y is 1/2, z is x1 is 1, x2 is 1/2, x3 is -1/2. You're done. For the part 2, you don't have to do. Part